Hello everyone, I am Vikas Meena. I am a first year undergraduate student at IIT Delhi, and today I am going to present my Ell project, which is based on usage of diode and different types of diodes in a mobile phone. So the first question is, what is a diode? So diode is basically a semiconductor device which is used to put some certain condition our voltage and current flowing in a circuit, like restriction of current to flow only in one direction and some things like that. So it can also be used to transform some signal waveforms into different shapes. Like from a AC current, we can generate a DC current. So a diode transmit current only in single direction, but they transmit with transmission way is very unique. That's why they are very important. So the working of a diode. So diode working depends on its arrangement. Like if a diode is said to be in forward biasing, if the external voltage is equal to it is in such a way that the voltage on the P side of the diode is more than the voltage on the N side of the diode. So here the applied voltage is opposite to the junction barrier potential. Now, like if in this diagram, if this is positive, there is inside there is a positive layer, negative layer is this side and positive this side. This electric field pulled outward the middle layer, and the junction barrier potential width continues to decrease, due to which majority of charge carriers flowing across the junction, and the diode behaves like a shunt wire. Uh, Forward bias PN junction forces majority of charges carriers to move across the junction. Now, if a diode is in reverse biasing, then the voltage on the P side is less than the voltage on the N side. And similarly, as discussed above, in this case, the width of the layer inside is barrier potential continues to increase. So this behaves like an open circuit, and this restricts the flow of current in opposite direction. Uh, Now, this is the circuit diagram. Now coming our types of diode in mobile phone and their function. So the first type of diode is LED or light emitting diode. These are that type of diodes which emit light when a sufficient amount of forward current passes through it, and the light produced can be of that wavelength that which is not falling in visible region, so they can not be even visible sometimes, and they can have different tricolor that they can emit three colors, and the light color also depend on the energy bandwidth, energy band gap of the semiconductor used. Next one is laser diode. A laser diode is a special class of diode because it produces coherent light. So this it is highly used in mobile displays and laser devices and display of several like laptops and other devices. And it emits radiation which is very harmful for living beings. That is only drawback. Now coming to Zener diode. Zener diode is most useful type of diode because it can provide a constant voltage. If the current through the resistor is in the level, then they can provide a constant voltage, and they always operate in reverse bias, and on the arrival of certain voltage they break down. Now coming to photodiode are very useful in the detection of light because they can detect even a small amount of current resulting from light. They are used in solar cells, photometers, and also in photoelectric effect to determine the current. Now coming to PN junction diode. PN junction diode is also known as rectifier diodes. These are used in rectification purpose. So PN junction is called PN junction diode because in these types there is a doping on the P side which is doped with P type material, and the N side is doped with the N type material, and therefore a junction PN junction is made something like that. That's why they are called as PN junction diode. There are some other types of diodes like signal diode. They are used for signal detecting and are made up of glass, and tunnel diodes, and they are used to process the properties of negative resistance and to make a switch at microwave frequency level. So now there are their diagrams. Technically, these are represented by these diagrams. So thank you. I am Vikas Meena.